Hey guys, I'm going to attempt to explain to you equilibrium through Le Chatelier's principles through some little videos I made. So we'll see how this goes. Like I said, equilibrium is not the easiest concept to understand. So I am just attempting this to see if this can maybe help you guys understand a little bit. So what I have set up here, I have a little bit of a balance set up here. So there's these two cups and they start level in all of these videos. And we're going to be changing something in each of these videos. So this first sequence is all going to be about concentration. Okay, so let's see how this goes, if this makes sense when I play this. So this first section is about concentration. And so I just want to remind you that this is the equilibrium arrow, and when reactants and products equal each other, or when the forward and reverse reaction is balanced out, then it's at equilibrium, it's happy. So kind of the way to think about this is if it's at equilibrium, it's happy. If it's not at equilibrium, it's going to continue to try to get back to equilibrium. So let's see what happens when we upset equilibrium. Guess I could have paused less. Okay, so let's say we increase a reactant, which is going to be in this cup. It's going to set it out of equilibrium. So watch as I add more concentration into the reactant side. Okay, you can clearly see that the scale is no longer balanced. It's not in equilibrium, it's not happy. So what it wants to do is it wants to shift back to the right. So like think of an arrow pointing this way. Once the fact that I'm touching this side means it's shifting to that side. It's shifting to the right, also known as the forward reaction. And so that is why it would go in that direction. Sorry, I'm probably pointing the wrong way, but it's going to do the forward reaction for that one. It wants to basically make more products to get back to balance because we added too many reactants. Okay, so this one is going to be similar, but now we're going to decrease the did I skip one? Yeah, sorry. So now we're going to increase the concentration of the product. So before we increased the concentration of the reactants, now we're going to increase the concentration of the product. So we're going to be manipulating this cup. So again, they're basically starting out at equilibrium. So they're happy, they're balanced. And again, that doesn't mean they have the same number in them. This is just showing that it's at equilibrium. Okay, so if we increase any product, it doesn't have to be one product or another, anything that we increase on this side, watch what happens to equilibrium. Not at equilibrium anymore. Okay, you clearly see that the scale shifted this way. So we're going to want to shift it back this way, okay? It's going to go back to the reactant side, which is known as shifting to the left, or the reverse reaction, because remember, this going in this direction is the forward reaction, going in this direction is the reverse reaction. And that's how that would get back to equilibrium. So let's move on to our third concentration video. And this one is we're actually going to decrease the concentration of the products in this case. So again, we start out as if it's at equilibrium. It's very happy. It likes to be at equilibrium. The reaction rates are equal. So it's at equilibrium. And now we're going to decrease any of the products. So I'm actually going to take stuff out of the product. There we go. I think I have to take some more out on this one. Okay, not at equilibrium. I made this side too light. Okay, now this part is up. So I'm going to want to pull this part down. So I'm going to, again, shift it to the right. You basically want to fill up the cup that is not filled up. So in this case, since this cup got lighter, I need to, again, shift to the right to fill this side up. Okay, and then last one for the concentration series. This one, I'm going to decrease the number of reactants. So starting at equilibrium, and it's happy at equilibrium. Reactants are at equilibrium with the products. We are now going to take away some of the reactants. Okay, it's going to take away some of the reactants. I'm going to scoop some reactants out. Makes sense that that side of the scale gets lighter. Okay, so now, and I want to basically fill up whichever one is lighter again. So I'm going to need to fill this one up, and I would do that by shifting this direction. I'm going to be making more reactants to get back to equilibrium. I just wanted you to take a look at this one for a second, because this, I like to tie this into climate change. So imagine that water and CO2, so H2O and CO2 are on the reactant side, and we talked about carbonic acid in the ocean being on the right side. And we talked about how we're making more carbonic acid because we keep making CO2, we keep increasing the amount of CO2. And so that's going to shift equilibrium. And since this side's getting so heavy, this side over here is going up, then we're going to shift this direction, we make carbonic acid. So how can we reduce the amount of carbonic acid in the ocean? Guess what? Get rid of CO2 in the atmosphere. Because if we get rid of CO2 in the atmosphere, it's going to want to go back this direction. If we pull out some CO2 from the atmosphere, if we stop burning fossil fuels, basically, the ocean will have an opportunity to reset its equilibrium. It will shift back this way. We will see less ocean acidification. Of course, that may keep CO2 fairly steady in the atmosphere for a while. Finally, will lower enough that everything will go back to balance. And so that I think is an interesting tie into our last unit. All right, that's it for concentration, and I will be making another one for temperature.